All right, we're moving on to lesson 0.3. So we're still going to continue working with functions, but now we're going to be working with compositions of functions. Our learning target is I can compose two functions. So this is our goal by the end of this lesson, is to be able to compose two functions. And we're about to learn what that is. So we are given the function g of x equals the square root of x minus 1 and h of x equals the absolute value of 5 plus x. We would be able to add, subtract, multiply, divide if we were given, say, g of x plus h of x. We know those operations, but what operation was used to get the absolute value of 5 plus the square root of x minus 1? Well, that's what we're going to get to today, because you can see essentially what happened is we took g of x, we took this function here, and we put it inside h of x. So what this is it's a composition of functions. And this is how we're going to denote our composition of functions. So there's two ways to write essentially the exact same thing. How this is said is g of h of x. So you can kind of see, like what we did in yesterday's lesson and the day prior, is say if we had g of 2, we would take 2 and we would plug it in to the function g of x, wherever we saw x. Well, now instead of plugging in 2, we're going to plug in an entire function to that variable. So let's look at our first example. So we're given 3 different functions, and I'm asked to find a composition of functions. So my first example is g of f of x. So this is just saying that we have a composition of functions, but like how I like to write this is what it's saying is g of f of x. It's telling me that I'm plugging in f of x to g of x. Well, what is f of x? F of x is x plus 2. So I'm just replacing it. Well, if I take g, I'm just taking this and I'm replacing it with my variable. So wherever I see an x in g, I'm going to replace it with x plus 2. And it is in the exponent, so we're writing it as like a little script up in the corner. So this would be my answer, 3 to the x plus 2. So now let's go ahead and look at f of g of x. So whichever one comes first is the one that we're plugging into. So I have f of g of x. So g of x is 3 to the x. So now I'm going to take this 3 of x and I'm going to plug it into my function. So I have x plus 2 as f of x, so I'm going to take 3 of x and replace that x, that variable. So I would have 3 to the x plus 2. And that plus 2 is not in my exponent. All right, for example 2, we're given the exact same 3 functions. F of x, g of x, and h of x are the exact same. So what I'd like you to do is I'd like you to find h of f of x. I'd like you to give that a try on your own. So go ahead and pause the video, try A, and then when you're done with that, hit play to go through and check your answer. Then we'll go through B together. All right, so hopefully you've tried it on your own. So now we're looking at A. So we have h of f of x. Well, let's replace what f of x is. So I have h of x plus 2. Now function h of x is the square root of 2x. So when I go ahead and replace that, I have the square root of 2, and I want to put this in parentheses because it's not just a monomial, it's a binomial. So we need to write that out. So now we have the square root of 2 times the quantity x plus 2. And we can go ahead and distribute that to kind of fully simplify our answer. So I would be left with the square root of if I distribute this in, 2x plus 4. And then that would be my final answer. All right, so if we're moving on and looking at B, we've got a slight twist here because we're not just plugging in h of x, we're plugging in h of 2. Well, first thing we need to do is find out what is h of 2. So that's going to be my first step. So I'll do that in another color. So my first step is going to find what is h of 2. So h of 2 equals, well, our h of x is square root of 2x. So where we see an x, we're going to plug in a 2. Well, 2 times 2 is 4. And the square root of 4 is going to give us a nice 2. Well, we input 2, we got 2 out. So if h of 2 is 2, I'm now going to take this and plug it in here because those are the same thing. H of 2 equals 2. So what I end up with is my end goal is, well, what is g of 2? So if I find g of 2, I have 3 squared. And 3 squared is 3 times 3, so we get a final answer of 9. And here is our last example. We have example 3. If f of x equals x squared minus 3 and g of x equals x minus 1, find f of g of x. So go ahead and pause the video, try this one on your own, give it a try, see if you can get it all the way fully simplified. Once you feel confident with your answer, go ahead and hit play and then review your answer. If you had any mistakes, you'll want to go ahead and fix those so that you make sure that you have accurate notes. All right, so I'm hoping that you tried this one on your own. We've done a few examples, so hopefully you were able to give this a try. So I have f of g of x. Well, what is g of x? G of x is x minus 1. So now into function f, wherever I see an x, I'm going to replace it with x minus 1. So remember, when we have a binomial, we want to use parentheses. So I have x minus 1 squared minus 3. So that is my composition of functions. However, it's not fully simplified, and our end goal is to always go for that fully simplified answer. Now, we know that, say, just like in our last problem, 3 squared equals 9. Well, why does it equal 9? Because anything squared is the base multiplied the amount of times of the exponent. So we have 3 times 3, which gives us 9. Well, if I have x minus 1 squared, my base is x minus 1, so I need to multiply that twice. So what this really means is x minus 1 times x minus 1. So that may have tricked you a little bit, so make sure if you didn't get that in your notes, you do go ahead and go back and fix that. So now I'm going to go ahead and distribute this in, and then I will subtract 3 at the end. So if I distribute this, I'm distributing my x, and when I do that, I get x squared, and x times negative 1 is negative 1x. If I distribute in my negative 1, I have negative 1x. Negative 1 times negative 1 is going to give me a positive 1, and then I have that minus 3 I can't forget about. So now I want to combine like terms, and I have 2 x terms and 2 constants to make sure I combine. So this gives me a final answer of x squared minus 2x minus 2. So that is f of g of x. Now, if you got that, you're a rock star. If not, believe me, we threw a lot of tricks into that one. Make sure you have that one down in your notes, as it may be something you'll see in the future. Now, if you feel super confident with composition of functions and you can meet that learning target of I can compose 2 functions, feel free to stop the video now. if you still want maybe one more practice, go ahead and continue the video as I've got one more extra practice for you. So way to go to not stop the video early and go ahead onto that extra example. So here's some extra practice for you. So we have if h of x equals the absolute value of 3x and f of x equals x squared, find f of h of negative 2 and h of f of x. So if you're feeling really good, pause the video and try these two on your own. Then hit play and go through and see, did you get it? Or maybe we need to work a little bit more, and it's a good thing that we have that 0.3 homework to get that little bit of extra practice. If you're still not sure, still struggling a little bit, go ahead and follow along. Make sure you get these down in your notes so you can feel a little bit more confident going into your homework. All right, so A, we have f of h of 2. So I'm going to rewrite this because I like to see it a little bit more like B. So what this is telling me is I have f of h of negative 2. So we did one like this. And first thing we need to do is find, well, what is h of negative 2? So that's my first step. So h of negative 2 equals, well, I have absolute value of 3 times negative 2. So I have absolute value of 3 times negative 2 is negative 6. And absolute value makes everything positive. So that means this is a positive 6. So h of negative 2 equals 6. So I'm going to go ahead and take this and replace that because they're equal. When I do that, I have f of 6. Now, I just need to find f of 6. So if f of x is x squared, plug in 6, and I'm going to find 6 squared, which is 36. And that is my final answer of f of h of negative 2. All right, and our official last example is h of f of x. So it's written in our nice form that I've been using this whole time. So I'm just going to replace f of x, our input. So I have f of x is x squared. So now I go to function h, and wherever I see an x, I'm going to replace it. And I have the absolute value of 3, now x squared. And this would be my answer to h of f of x. So hopefully now we feel a little bit more confident with this. So go ahead and try your 0.3 homework, and it'll give you more practice of this learning target of I can compose two functions.